I go there and I want to change things, right? Like I said, like I'm a wartime CEO. I'm not a peacetime CEO.
George Hotz, welcome to Software Engineering Daily.
Hi, good to be here.
Yeah, so I'm sure a lot of people know you from jailbreaking breaking devices or working on self-driving cars or marathon Twitch sessions. But for those that don't know who you are, could you give a little intro background on who you are, what you've been up to?
My name is George. I'm a programmer. I've been programming for like 20 years.
Nice, I love it. So for those of you who don't know, George is a bit of a celebrity. How old were you when you jailbroke the iPhone? 18 or so, something like that.
17. And I didn't do the first jailbreaks. I did the first unlock.
Okay, okay.
Uh,
So
but I did it with a technique that some guy, oh man, he's still on Twitter 20 years later. Bro, you stole my technique. I'm like, what do you mean stole it, man?
yeah,
Oh, you got a copyright on that? Come sue me, bro. Nah, don't sue me. Don't sue me. You can name my website, though.
yeah, cool. So jailbroke the iPhone, jailbroke PlayStation, all this cool stuff, and then 2015, 2016 released this self-driving kit that you can just add to not any car, but almost any car. You can hook it up to a huge variety of cars. So not starting from the ground up like Cruise, Waymo, Tesla, things like that, but actually modifying existing cars. Been working with, and that became comma.ai. You recently left comma.ai, but can you tell us a bit about, I guess, like how it went over the last 5 or 6 years? What did you learn? What changed? Are you bullish on the industry? What are you thinking?
Well, so first off, the main reason I left was there just wasn't that much for me to do. Right? Like, we have really good people in place who are executing on the plan. I go there and I want to change things, right? Like I said, like I'm a wartime CEO. I'm not a peacetime CEO. No, I mean, I think they're doing a great job. And I think that the way to write good software is to write it 3 times. So everything gets rewritten and everything gets improved, right? And this is a very slow process. The same thing's true about hardware, right? There's a reason the iPhone 14 is so good. It's because of the 14, right? So it's just a slow grind.
So do you like to write the first version, but don't love the second and third as much?
Yeah, it's. I like the first. I like this. I feel like once I can, as long as I can conceptually improve things, I'm down to keep rewriting it. But once I kind of run out of conceptual improvements and it just comes like, well, okay, you just got to do this. Well, then I'd rather hand it off.
One thing, a couple of things that were different in your approach at Carmack compared to other places. One, I think, was in sort of like the segmented approach versus a more end-to-end approach that you took. Can you talk about those differences? Do you still think that the end-to-end approach that you took at Comma is the right approach?
Oh, unbelievably, I think we could even almost go more end-to-end today. So what Comma really is we built a simulator. And then we train our models in this simulator, right? And this is second paradigm model. So we're talking about first paradigm models were these models that we hand-coded lanes and cars. And it turns out with lanes and cars, you can do a lot of driving. But then it becomes really hard to do something like, say, drive through an intersection, right? Just like drive through an intersection, because there's no lane lines there, right? Yeah. And you could say, okay, I'll detect the lane lines on the other side and interpolate the path, but it's not really good. So this was first paradigm models. We're like, how do we fix this? And we fix this with second paradigm models. So second paradigm models are trained in a simulator. But what's notable about this simulator is it's not like a car law Unreal Engine style simulator. We call it the small offset simulator because it uses real routes, loads them in, and lets you make small deviations from what the car actually did. Right? So you can load up a route.
Which way? Yeah. Okay.
Well, laterally or longitudinally, right? So like there's like the real path of the ego car. And then you can change that by kind of just visually shifting stuff, right? You get the depth of everything, and then you can like reproject. And this solves a really fundamental problem. We call it behavioral cloning, but it means a lot of things. Like if you just take a model and you just predict the human path given the picture, this will not drive a car. And the reason it won't drive a car is because your samples are not IID. Right? When you're training a classifier, the first image is an image of a cat, right? And it says cat or it says dog. But it doesn't matter if it says cat or dog because that doesn't affect what the next image is. Right? This isn't true in driving. If you have an image and you predict go left, the image afterward changes. Your predictions affect the future. And this is why standard supervised learning techniques don't work at all. On driving, this is why you have to train in a simulator. So we train in a simulator. It's some hybrid of supervised and reinforcement learning. And this is, I think, the most extreme of anyone in the industry. But I would like to go even more extreme. I would like to go where we at least train a really powerful foundation model. And we're moving in this direction. A foundation model, we train an autoencoder on the visual features. You can look, like when you look at stable diffusion, the outside of stable diffusion is an autoencoder. Meaning like you can do dimensionality reduction on the image in a completely unsupervised way. And then the second part is a really powerful dynamics model, just a predictor. And you can these autoencoders will output things into discrete spaces, not continuous spaces. And the cool thing about a discrete space is it's like language, right? So you can break the picture down to say 64 words from a vocabulary of 1,000, and then you can use GPT style techniques to build predictive models, right? GPT is also working on like a vocabulary of like 1,000, and 64 words is very much within. So yeah, we're getting close to the true dream, and we call this third paradigm models.
Okay, I want to talk a lot more about AI as we go, but so building a simulator, is the purpose of having the simulator just it's much cheaper to sort of have a simulated world and make changes as compared to like driving it out in the world and trying to get better on that video?
No, you can't. No, so the problem, okay, the simulator allows you to train on policy, right? If I gather video, if I take a car out, right? Let's say hypothetically I want to train on policy with the car. I could load my models onto the car. I could go out and gather data, and then I can take one more step in those models and then load the next models onto the car. But the problem is you have to do this every time you train, right? We have tons and tons of data. We're not data limited at all. But the problem is all that data is off policy when you're training a model, right? In order to get on policy data, you need a simulator.
Gotcha. Okay, sounds good. When you say, what do you mean off policy, on policy? Just to clarify that.
Well, these are reinforcement learning terms, right? So on policy, okay, so you can think of reinforcement learning as like you have a state at time t, and then you take an action, and then you have a state at time t plus 1, right? Yeah. So when you're on policy, your actions came from your current model, right? When you're off policy, the action could come from, well, actually the human who drove the car, right? So it's much harder to learn off policy than on policy because your model didn't take that action. To be honest, like a lot of this stuff is like these are very standard terms. Like everyone who knows reinforcement learning knows that stuff, but there's not many theoretical guarantees for anything about off policy. This is one of the things we really explore at Comma because, okay, a lot of off policy learning depends on noise, right? If you are training on policy, let's say you have a model that knows nothing, right, and does completely random actions, right? Well, it turns out with completely random actions, you can like understand what those actions do. If you're off policy and you have rollouts with no noise at all, well, okay, tell me what happens if I'm driving down the highway and I go like that with the wheel. Yeah. Right? You don't have that in your data set. Yeah. So maybe it's a good action, right? You don't know.
Yeah.
See, and this is the problem with off policy. But on policy, your model will just do that and be like, oh, well, okay, maybe I don't do that.
That was a mistake. Okay. So you've talked about Comma being like the furthest down the road, at least on this simulator thing. What do you think of the other approaches, especially with Cruise and Waymo and seeing more of their actual driverless cars in the world? What do you think of that?
The problem with Cruise and Waymo, and I've always said this, people think that like my dispute is about LiDAR or maps or something like that. And I think LiDAR and maps are dumb. But I don't even think that's the fundamental problem with Cruise and Waymo. The fundamental problem with Cruise and Waymo is unit economics. Right? Each one of those cars costs like $500,000. And what product does the car provide? Well, it's like Uber, right? But is it as good as Uber?
Probably not quite. Yeah, for the customer. Yeah, a little slower.
And why not?
I would just say, like, there are some. It's probably safer, a little more cautious in certain ways that that don't actually benefit the driver experience. Like maybe slightly overstopping at certain things or
Yeah,
at certain things.
yeah. It takes 50% more time to get anywhere because it has to come to a full stop at every stop sign because that's what's coded in the software. Whereas my Uber driver came to a full stop at every stop sign. Look, I mean, this isn't what I right, and this is a very fundamental problem, right? This is not a problem that like can be fixed. These things are going to be slower. These things right now are more expensive, and you're like, okay, with scale it could come down, but like, how much scale? I think that some six-figure software engineers sometimes forget how much money an Uber driver makes. In fact, I was a friend of mine drove for Uber, and I looked at her Uber stuff, and I'm like, yo, you're losing money, right? You understand you're paying more for gas. She's like, I like it. Uber preys on people who are bad at math, right? You literally are getting drivers to subsidize. So, it's
not thinking about depreciation and all the wear and tear they're putting on the car. Absolutely.
When you truly factor in everything, a lot of kind of hobbyist Uber drivers lose money. Which another way of saying lose money is give free money to Uber, right? So I think that this is the main problem with Waymo and Cruise. It's a very fragile managed system that costs a lot of money and may not provide a product that's competitive on the market.
In terms of so it's two things. It's slower, but then it's also costs more. That slower aspect, will that also be true for Comma, or do you think Commas will actually be a better driving experience?
We're not trying to be level 5, right? Okay. Or level 4. And then this is sort of a key distinction, right? If you ever don't like what your Comma's doing, let's say, let's say it takes a turn too aggressively or not aggressively enough. Okay, take the wheel and change it, right? And that's the distinction. So our policy doesn't have to be this ideal policy. It's an assistance system.
Yeah. Well, on that same note, I saw you on Twitter recently, going back and forth with Gary Marcus a little bit and saying L5 by the end of the decade.
Yeah.
Tell me about that. So you don't think Comma's the one that's going to get there?
Oh, I think it's very possible. I kind of think that by the end of the decade, it's just going to be pretty easy. In the same way right now, it's pretty easy to train like an unsupervised chess engine. I think that the techniques will just become a lot better, and the software frameworks to train these things will become a lot better. The compute will become a lot more available. So I don't think it's going to be particularly tricky. I do think by the end of the decade, assuming Comma continues on its path, we'll have pretty much solved it. Yeah. I think Tesla's going to beat us by about 1 to 2 years. I think there's a decent chance we get second.
Yeah. Based on what you thought 2 years ago or maybe 4 years ago, do you think you're ahead of, behind, or sort of on track with how you predicted that?
In the very beginning, I was over-optimistic. But I think I corrected pretty quickly on that, and then I think it's pretty much where I thought we'd be.
Cool. I want to talk a lot more about that state of AI stuff that you mentioned around hardware and software. But a few more things on Comma, like what benefits or downsides do you get from having sort of like a post-install kit rather than building a car from the ground up? Is it mostly a price thing? Are there other benefits in making the product evolve faster?
Honestly,
or what's that like?
I don't care about this stuff. Our Comma's mission is to solve self-driving cars while delivering shippable intermediaries. We use the hardware to fund the company. It's very important to me to be profitable and to make a sustainable company. But like aside from that, people are like, George, but what are you going to do when the car is like locked down? Like, who cares? We're here to solve an AI problem. Right? And I think that's something that's lost on a lot of people who live in this world where their companies are trying to be on some like optimality curve all the time. Like, I don't care. We raised a small amount of money from a bunch of people who, like our latest round of investment, like these guys are like, they're down for the mission, right? None of them are here like, look, I don't want to squander your money. We're going to try our best to seriously, sell 100,000 of these devices, 100 million in revenue. It's pretty good. But like, the point is solving self-driving cars. The point is not to make a business that makes money.
How have you been so capital efficient? Because like you're saying, you've raised, I think, 18 million, and for a long time it was 8 million. And I see web-based SaaS apps that are raising 100 million and just shoving data in and out of a database. I guess, how have you done that while shipping hardware and iterating on a hard space?
Yeah, I mean, if you cut out all the useless people and stuff, you don't need that much. Right? This is what hacking is. Hacking lets you drill down to the absolute minimum. Like, okay, what is this, right? Look, we got our boards. They're routed by one guy. He's very, very smart. And he designs the things, right? And he does it slowly over time. It takes time. But okay, but why do I need a team of 10 people? See, you need a team of 10 people if you want a marginal speed increase, right? Say you need the product to be ready 2x faster. Then you might need 10 people. But this is Amdahl's law. People don't scale very well. So when a lot of these things are not a question of doing a lot of things, but just doing one thing very carefully and correctly, it doesn't help you to have more people. And then more people is a big cost to this. And then everything else is just, look, I'm a middle-class guy from New Jersey. When I look at the price of something, I'm like, is $20,000 for a couch? No, it ain't, bro. Whereas some startups would be like, yeah, we got to buy this couch. It's from Design Within Reach. And I'm like, dude, growing up, we go to IKEA. We get a couple guys. We put it in the back of the pickup. That's what we're going to do.
Yeah. How many people work for Comma?
23.
20. That's amazing.
22. I don't work there anymore.
Yep, sure. Okay. Tell us about what's next. You recently left Comma. What are you working on?
So I'm working on tinygrad. I'm trying to build. So I think PyTorch and TensorFlow are the Fortran and COBOL of deep learning programming languages, right? I wasn't around for Fortran and COBOL. I can only really talk about what was there, but I think that these things are they're very clunky, and TensorFlow in particular, right? We switched from TensorFlow to PyTorch maybe 2.5 years ago. And the thing that really drove me over the edge was a parameter in the TensorFlow optimizer called clip norm. Clip norm is this thing you do, it clips all the norms. And we were putting in a number and it wasn't changing the behavior. And I was like, huh? And then we look. Read the code. Clip norm is broken. They didn't add an assert. They're just broken, right? And I'm like, all right, this has to go. We switched to PyTorch. But PyTorch has similar sort of problems. Right? It's very hard to go into the PyTorch code base and read, okay, I want to do a ReLU. Okay, where does a ReLU happen? Well, it's 4 layers of indirection and all these specialization things and all these. And then I think that software, I think this is pretty well established that the amount of bugs in your software correlates to line count. So,
yeah,
can I write a deep learning library that's competitive, actually faster than PyTorch with 1,000 lines of code?
That's amazing. I was looking through it. Just for, I guess, comparison's sake, do you have a sense of how long PyTorch and TensorFlow are? Lines of code?
Yeah, so the core parts of PyTorch, let's say 10,000 lines and 100,000 lines, right? Now, in reality, the repos are 100,000 and a million. But let's say PyTorch is 10x bigger and then TensorFlow is 10x bigger than PyTorch.
Yeah. Okay. And so is TinyCorp and tinygrad, is that your main focus right now?
Yeah.
And
you can look at my GitHub. I'm hustling.
Yep.
I've been coding a lot since I left, so whenever my GitHub's green, I'm happy.
Yep. Good. And will you hire other people? Will this be your own project? What are your plans for Tiny?
I don't think so. I think that people who want to contribute are welcome to contribute on GitHub. My hope is if it starts to get adoption, the companies will start to contribute to tinygrad. And then effectively, in fact, we say this about openpilot too. There's probably more people being paid full-time to work on openpilot outside Comma than inside Comma now. And this is really cool. I mean, this is how you know you're starting to succeed as an open source project, right? Maybe when I was younger, I was more a fan of GPL style things, but I switched everything to MIT. And what I see about open source is the reason that somebody wants to upstream their thing, right? Okay, you're okay, fine. Why would I upstream it, right? Because we'll maintain it for you. If you're a company, let's say you're a car company, you want to get your thing let's say a small car company, right? You want to get your thing upstreamed into openpilot, so we maintain that code. When we do refactors, right? Look at the beauty of this. Linux kernel is the same way. Right? You don't need GPL to do this. When someone refactors the PCIe subsystem, you want your PCIe driver to keep working. And now it's someone else's responsibility once you've upstreamed it, right? And this is the beauty of open source. And it can work in such a way that it's worth it for companies to contribute back to these projects. Right? So that's my whole point.
Which companies outside of Comma are paying engineers to work on openpilot to get stuff upstream?
So there's several Chinese car companies. There's another one. There's some guys down in I think they're in Vegas doing like full self driving sort of stuff. Right? It's just like everybody who. There is no reason today that you should start an ADAS system from scratch. Everyone who's doing it is an idiot, and they should use openpilot. It's really good, right? Not only is the model and stuff really good, but the infrastructure of the whole thing is really good, right? We built, so like ROS is, a lot of people use ROS for robotic stuff, right? ROS is, we thought about using ROS. Okay, and like you can look at like two core components of ROS. There's the serialization and there's the messaging, right? So ROS built custom versions of both of those things. We start out in openpilot with saying, okay, we're going to use capn Proto, right? Capn Proto, so it's like Protobuf, but I think Protobuf's really bloated. And then we're going to use ZMQ, right? ZMQ, everyone should know, it's a very common socket library. We actually moved off of ZMQ because if two processes want to communicate, ZMQ uses sockets, and you're going through the kernel. You're making a copy. So we switched to a custom thing called message queue, where you can process B can access the shared memory of process A. Like process A creates a ring buffer, and then it's pub sub. But it's compatible, right? You can still run all of openpilot with ZMQ equals 1, and it'll fall back to ZMQ, right? And like these messaging and serialization things are the best on the market today. Everybody should start using them, and there's a few people out there now are, right? Like I think somebody might be gooddog.ai. They're like doing robotic stuff, and it's like, oh yeah, use openpilot, right?
Yeah. So you mentioned a bunch of companies using openpilot, and then on the tinygrad website, you've sort of mentioned that you'd be willing to embed with a company to sort of, if they wanted to sponsor you. Do you have any ideal projects or companies that
we had a discussion about a contract with a large AI chip company. The contract kind of felt, like these companies are bloated and hard to work with. But I think as there's companies, multiple companies now, Cerebus, TensTorrent, GraphCore, that have done tape outs of these chips. And they don't have software. They don't have a functioning PyTorch port. In fact, PyTorch just shipped MPS, which is metal performance shaders. And I found a bug. In their matrix multiply. Right? It's not that matrix multiply is wrong, but one of the things is like transposed, and it didn't take the transpose into consideration. I found this on stream when I was doing my tinygrad, my stable diffusion port to tinygrad. And I'm like, wait, tinygrad's got to be wrong. There's no way PyTorch is wrong. Wait. Yeah, and it was wrong. Right? Only for MPS. Obviously, when you go back to CPU, if you're on x86 and NVIDIA, this is not going to be a problem. But and it's because it's really hard to do a port of PyTorch to a custom accelerator. You have to port tons and tons of operations, write a lot of code. Whereas tinygrad, it's really one operation.
Interesting. And it works with all these different accelerators.
Well, it could. It's really easy to do a port. The amount of code you have to write to port tinygrad to Windows Accelerator is 100x less than the code you have to write for PyTorch.
Okay.
And I mean 100.
Yeah. Okay. Tell me about the state of AI generally, which I think factors into why you're doing tinygrad. I guess what are the hard parts in AI? Is it software related? Is it hardware related? Is it engineering related? What's hard there?
Well, everything's hard and everything's easy, right? If you look, this is a Eliezer Yudkowsky thing I love. If you look at factoring algorithms, right? Would you rather have a 1970s factoring algorithm on modern hardware or a modern factoring algorithm on 1970s hardware? And so you think you'd rather have a 1970s factoring algorithm on modern hardware?
That's what I would think, yes. But am I wrong on that?
You are.
Really?
But not by much. Not by
Okay.
much.
Yeah.
Not by much. Factoring algorithms have come back in the 70s. You're using maybe something like Polar's row. Now you use a fancy general number field sieve. I think the exact same thing is true for SAT solvers as well. Would you rather have a 70 SAT solver in modern hardware or a modern SAT solver? And modern SAT solvers are much, much better. In fact, I just got Art of Computer Programming 4B, and half the book's about SAT solvers. And I'm like, oh, this is great.
Yeah.
I think SAT solvers is this amazing thing to think about. And so yeah, I think like factoring and SAT, like these like hard problems, right? I think SAT we know is an NP. I don't think factoring is an NP, but the algorithms have progressed faster than the hardware, but not by much. So I think the same thing is going to be true about AI, right? It's interesting that like they're pretty close, and software has a shorter REPL time, so I think you can make progress on software faster than you can hardware, but not by too much, right?
Yeah.
So yeah, I think the same thing's true about AI, right? I think that the software is bad, the hardware is bad, the algorithms are bad. Right? But what do you mean by bad, right? Like, sure, just because they'll be better in the future doesn't mean they're terrible. They're a lot better than what we had. Oh man, you trying to do this stuff 20 years ago? What are you? GPUs are like not general purpose. You have no frameworks. You're hand coding all your forwards and backwards passes. Your algorithms are like stochastic gradient descent. You don't have atom, you don't have batch norm, you don't have dropout. Like,
yeah. What does the development process look like when you're sort of iterating on AI? I sort of think of like build up this model and then go set it to train for hours and hours and hours. Is that true, or is that like an outdated one? Like, what does iteration look like?
That's true. What do we do at Comma? We spend most of our time writing tests. Right? Now, of course, these tests
how do you
are
test that? Like, what does a test look like?
all sorts of things.
Yeah.
So tests kind of fall into, we can say, two buckets, right? There's tests of overall performance and there's tests of like specific performance, right? Maybe the same things are like, maybe you can say they're integration tests and unit tests, right? It's the same basic ideas. A lot of Comma, like I say these things and these are like, one of the things is I just got bored saying the same things over and over again at Comma. And I hope the people at work, they don't feel the same way. Right? Like I hope that people, I don't know, maybe this is something about me, but like we've been saying, I feel like we figured it all out. It's just now a question of doing it. But a lot of the stuff is like testing 2.0 methodologies, right? Like, yeah, how can we say one model is better than another model? Right? We have two models. How do we say which one's going to drive the car better? Now, well, if you're in a very early stage, you can actually go out and try them both on a car, right? But this doesn't work as your models get better. If you have models that one model makes a mistake every 1,000 hours and one model makes a mistake every 10,000 hours, well, you're not going to test that, right? What are you going to do? You got to go drive for 1,000 hours, right? And that's okay. Now, so you have to come up with better testing methodologies that can discover these things without needing a car.
And what do those look like? Do you run it just through a simulator and see how many mistakes it makes, or what's that look like?
So simulators are one tool. We use tons of different tools, right? Yes, we definitely have the simulator. It's called Analyze Lat. Analyze Lat runs it on 2,000 segments and tells you how it does.
Yeah. How do you? Maybe this is a dumb question, but like you have all these simulators, but you also have a bunch of people with Comma installed in their cars. Do those match up pretty well with where like, hey, if you run through a simulator, like, hey, this is a big improvement. We've moved it from 1,000 to 10,000 errors. Do you find that's true when it gets out in the real world?
For the most part, yes, right? And then whenever we surprised, whenever we find that we ship something to the real world and, we put these on our master branch and there's maybe like 10% of the Comma fleet running the master branch and they're on Discord and they're like, bros, everything's great, but every time I go through an intersection, it slams on the brakes. Oh, well, that's not a real example, but a lot of the stuff is way more subtle than this. Like exit splitting is something. Like it'll like take exits on the highway when it's not supposed to, right? It doesn't know which path to take. So whenever we get these complaints, we figure out how to validate them in simulation, and then we add that to our test suite.
Okay.
So whenever we're surprised, now we have a new test, right? And now it has to pass this entire complicated test suite before we ship it. So yeah, the whole problem, the actual iteration on the model is not most of the work, right? The model, it doesn't matter. It really doesn't matter. It's about testing.
How is the AI hardware market right now? I know like NVIDIA, the big one in the room, but we also got TPUs, we got Apple now. Like, what does the hardware market look like?
I'll say one more quick thing about testing, and I'll go into that.
Yeah, sure.
My point is, like, if you have a test that's good enough, well, that kind of is all you need, because, okay, I'll just do a random search across a model space, right? If I have a test that can always tell me which model's better, okay, I ship it out, train 10,000 models, and tell me which the best one is. Great. Right? And I can do automatic search, right? I can search in a space if I have a good evaluation function. Yeah. But that good evaluation function is really hard to build. The hardware market, we love low stock price NVIDIA. High stock price NVIDIA is like, oh, we're going to gouge people and it's going to be terrible and we're not worried about anybody. But low stock price NVIDIA is like, we're going to open source our kernel driver. And the 4090s are amazing. Oh man, they built an amazing chip. Well, a few things about the 4090s are so incredible. So one of the biggest problems on the 3090 was it only had 6 megs of L2 cache. The A100 had 40 megs. So a lot of the benefits from A100s actually just came from the larger cache size. But the 4090 has 72 megs.
Wow. Okay.
So they didn't up memory bandwidth that much, but they added this big L2 cache, which effectively gives you a lot more memory bandwidth, especially at the size of models we're training. So yeah, that's really exciting. The chip is 5 nanometer, 4 nanometer, even like it's a massive chip too. It's the thing's like 600 square millimeters. So yeah, I mean these chips are amazing and they're not that overpriced. Like a 4090 you can get for $2,000. So right now, NVIDIA is a king, but. Yep. No, TPUs are useless, right? And you know why TPUs are useless? Because where am I going to get them? I'm going to go Google Cloud.
Yeah. Google Cloud. Is it still a licensing thing? I know I was listening to you on Lex about that, where they sort of have restrictive things that you can do with TPUs. Is that still true?
No, a friend of mine at Google's like, George, this can't possibly be true. And he's like, well, it actually is true. And they fixed it, right? The idea that like the TPUs, like if you train self-driving cars on our TPU, that term was only meant to apply. I think someone from Google really has to address this, but that term was only meant to apply to their like machine learning hosted thing. Like they have like access to a cloud suite of Google models. If you train your own model and you rent bare metal hardware, it doesn't apply. But like, I don't know. I just don't want to deal with any of this.
It's scary enough and uncertain enough that you just don't want to. Yeah, just
we built an incredible. We built a compute cluster in our new office. It's so good. Hundreds of GPUs, thousands of cores, petabytes of storage, and it's like ours. You can go touch it.
So is all your training done on-prem in your office? Yeah.
All training's on-prem. All our you can download the Comma app. It's a cloud dash cam. That's all Azure. But for training, GPUs the cloud is a good deal as long as all you want are CPU cores, right? The minute you need storage or GPUs, the cloud's a huge ripoff, right? And what is training? Storage and GPUs.
Yep. That's interesting. My brother-in-law, he does machine learning stuff, and he's found the same thing where he's just building his own boxes and renting server spaces because AWS is just killing him on that. So
if you can pay for low priority CPU cores, most of your bandwidth is ingress, then the cloud's a phenomenal deal. Love the cloud.
Yeah.
But the minute you need anything specialized, or storage or egress bandwidth.
Yeah, exactly. They kill you there. Tiny also talks about training on the edge and that aspect. Why is training on the edge so important and necessary?
So this is a shift that I see happening. It's going to be still 5 to 10 years, but. The fact that there's any distinction between training and inference, I think, is absurd. Right? Humans don't have this distinction. Humans train all the time, right? And your systems are always going to be rigid and inflexible if they're not lifelong learners. If they're not constantly training, if there's okay, we're just going to freeze the weights of this thing. Imagine a turn, right? On let's say it's a blind turn, right? And let's say when you're looking at it, it's kind of unpredictable. It's not exactly clear what to do, right? So it's not that Comma is not going to be able to do this turn. But every time it takes this turn, it's going to need to it's going to miss it and then overcorrect, right? And that turns out to be what humans do every time the first time they see the turn. But the key is it's only the first time. You drive that commute every day. Okay, maybe the second day you mess it up as well, but by the third day you're like, oh yeah, I remember this, right? And that's because you're a lifelong learner. So I think that we're going to have to move towards, lifelong learning on device. And that's one of the things that I really want tinygrad to support.
And does that feed back into like the main centralized model that then gets pushed out to sort of master on everyone, or does it stay on that device, some of that learning?
Well, yeah. So we already have some on-device learning, right? We have something called Params Learner. Actually, we just we're shipping a big upgrade to it for Black Friday. Params Learner can. Okay, so here's an interesting fact. The wear on your tires is a factor in how much torque you have to put on the wheel, right? And this is pretty obviously true when you think about it. If you have fresh new tires, well, they grip the road a lot better. So you turn the wheel. You put less torque on the wheel to make a turn, right? But if they don't grip that well, right, just imagine like some tires sliding, right? So one of the things we learn on device, this thing called Params Learner, is the tire stiffness. Not with a tire wear, or my vehicle dynamics is not great. But my point is we have this on-device learner. But this on-device learner is learning a bunch of hand-coded features. Now the real thing that you want is to get rid of those hand-coded features. You want to say, okay, here's the desired path. Here's the actual path. All right. You got a reward function to match those things.
Yep.
Now make that stable. It's hard, but
if you're doing a bunch of on-device learning too, will it sort of pick up even my preferences or different things like that are different from person to person? Just if I'm a little more cautious on some of these things, or
it can. It depends what the reward function is, right? Yeah. So right now the Params Learner, which again it is a learner, right? It's using the derivative and it's updating a set of parameters based on the derivative of the error. It's just at some point like when is it? It's not deep learning; it's learning, shallow learning. So the reward function there is only trained when the computer is engaged, right? The weights are not updated when you're driving the car. So if you want the weights to update when you drive the car, see, like the eventual final like model for comma is disengagement is negative reward, right? Like you taking over, you correcting the car is actually the only thing you need in a reward function to solve self-driving cars, which is really cool. But that kind of stuff probably works better at fleet scale, right? To try to learn that from you, maybe that gets even fancier than what I'm asking for now. But yes, eventually, sure, you can have a conversation with it, like, bro, slow down. I got you. Don't worry. I got a fancy LLM, modeling, bro, slow down, embedding it in a vector space. Right?
Yeah. What's holding back stuff at the edge right now? Is it software? Is it hardware? Is it tinygrad isn't complete yet? Yeah.
Okay. It's not one bottleneck, right? You ask the same question, like what's holding back factoring, right? What's holding back SAT, right? Well, it's hardware, it's software, it's algorithms, it's all those things.
Yeah.
Okay. Right. So yeah, maybe you can really break it down into those three things. So you can break it down into hardware, which is straight up like how much flops can we shove through this thing. We can break it down to like software. When I say software, I mean infrastructure, right? Like infrastructurally, okay, how can we maximally utilize the flops? How easy is it to code things in this? How easy is it to debug in these sort of spaces? How easy is it to update when new accelerators come out, right? So that's like the infrastructure component. That's what tinygrad is. Right? Tinygrad is not a hardware company. Tinygrad is an infrastructure company. And then there's algorithms. Right? And then algorithms are, comma is also really an infrastructure company, right? Like we try to say, we have a saying at comma, like don't do research, right? Because you're not going to compete on the research with these overfunded AI labs of Google and Facebook and stuff. Read their papers, implement it, apply it, and ship it. So yeah, then there's this quadrant of algorithms, right? And algorithms are currently dominated by DeepMind's made a whole bunch of advances, OpenAI, the big AI labs are where you get the advances there.
Yeah. Speaking of the big AI labs, like there's a lot of, I would say, excitement recently about language, art stuff with DALL-E, Stable Diffusion, things like that. How does that interact with self-driving? Like, are those totally different domains, or are they helping each other?
I mean, there's a few cool things. Like I spent a weekend. That's one of my better streams. I spent a weekend implementing stable diffusion in tinygrad.
Yeah.
It's just cool to go through and like see what all the things are. I don't know. I'm not impressed with these things.
Okay.
I think they're like, I've seen classical systems from 20 years ago that could do similar stuff. Right? Like there's some cool things they can do, but they're not superhuman, right? In the way that I'm one of the AI things that, and I'm not like a total AI hater. I'm just not that impressed with this compared to something like Mu0 or AlphaGo, right? Mu0 is one of my favorite papers to come out of all time. They're like, you can from nothing with little access to a simulator learn how to win chess, Go, Atari, and Shogi in the same like architecture. Now this is incredible. Or another paper came out, Iris. At first I read it and I'm like, oh, this is like a research write-up, but it is a research write-up. They didn't come up with new ideas, but they did it well. It's Atari games which learn a simulator and then train in that simulator, and this is cool stuff, right? Whereas like, yes, great, your language model, look, it understands poetry. Who cares, man? You know, like you could give these people a Markov model, tell them it's some fancy AI, and they're like, oh, it's got such deep insights.
Yeah. Yeah. All right, that's good. I want to switch tack a little bit. Like, you know, you've hired some people. I know at Comma you said it's hard to get into Comma. It's hard to stay at Comma. What types of skills or backgrounds have you seen that work well in AI? Work well at Comma? Like, is there, you know, do you need this hard math background? Do you need good software engineering background? What do you see?
Our interviews are, I'll just ask you a bunch of rapid fire questions, and they're not like hard questions. I ask you like, what's the complexity of matrix multiplication? What's the speed of light? Right? Like basic things that, you know, you should know. Or even stuff like what's 13 in binary, right? And if you don't like right away say 1101, like you know, it's whatever that is it's like a fluency with computers, and that's what gets you hired, right? It's like you've spent a lot of time doing this. When you're in the shower, you're thinking about this stuff, right? It's I hate the word, but it's kind of passion, right?
Yeah.
And someone like can say all they want, oh, I'm passionate, right? Anyone who writes in their email, I'm passionate, immediate. But you show me your passion when you get excited when I ask you questions like that, right? Like, yeah. Do you know a huge breadth of knowledge? Our infrastructure interview, and I can give away the whole interview. Here's the question. I ask you, I type google.com into a web browser, what happens, right? Now, I like the people right away who are talking to me about keyboard interrupts, right? And how that ends up in the browser, right? And then, you know, there's some people who like, and then it does a DNS lookup. Okay, what's a DNS lookup? Well, there's like a DNS server and it connects to it. Okay, how does it connect to it, right? And you better talk to me about port 53 and syscalls, and right? You know, you don't know that stuff. Like, yeah, you're not gonna work with Comma, but you know that stuff. That's a good job.
Yeah. I think of you as a passionate person and just like extremely high energy, and I'm just kind of amazed that you can go on Twitch and live stream for 10 hours or so. You know, I don't know, you're getting older. You're still young, right? You're 33, but like, do you sense a change in your stamina or passion, or are you still like just as fresh as you always have been?
No, I think this stuff starts to decline maybe in your 40s. Like, I think I got many years. Then you look at like John Carmack, and like that guy's got more stamina than I do, right? You watch people like how do you stream on Twitch for 10 hours? Like, I don't understand. Do people not have jobs where they work 8 hours a day? Like, I'm just baffled by this. It's like sure, if I streamed on Twitch for 48 hours, you're like, how does this guy do it? 10 hours ain't that much, bro. And it's not like I'm spending 10 hours every minute working. You know, you watch me take breaks and go off on internet tangents. And yeah, I would probably say I get like 6 hours of work done in those 10 hours. Like, is that not what people do at work? I don't know.
You know, not anymore, I guess. We've all gotten fat and spoiled and lazy.
Yeah, I mean, that's just like weird to me. Like, yes, if you work at Comma, you're probably going to, you know, be in the office 10 hours a day, and you probably work 6 of them. Like, okay, that's just the most normal job to me.
Yeah. I forgot to ask you mentioned what gets people hired. What gets people fired? Because you said you fired people as well.
Gets people fired. A whole bunch of things. I mean, the easiest way to get fired is to just kind of stop doing work.
Yeah. Do you see that a lot?
True. Do we see that a lot? I mean, yeah, people, not everyone is and I respect the people who quit. I respect the people who say, look, I'm not really feeling this anymore, I quit. Some people are not that self-aware or kind of are nervous and then don't quit, and then, I'll fire you. So there's that. Soft skills can get people fired. You're just arguing with people and you're going to work with, they'll get fired. Or you can't ship things, right? You've worked at Comma for 6 months and you haven't shipped anything. That's not good, right?
Yeah.
So, but yeah, you don't ship things. And I'm not saying we value super teammates who communicate well. I'm not saying that, but if you're pissing people off, well, you're gonna get fired, right? That's just normal. Yeah. Don't piss people off. Ship things and work hard, and that's it.
Yep. All right, I want to talk to you about some tech current events. Let's talk crypto a little bit, just because we've got the FTX, SBF.
Caroline.
Yeah, right. And I know I don't know where you are in crypto. I know you've done a little bit of stuff, including helping some team that you met at a restaurant and you solved some mega problem for them. But I guess where are you on crypto? What do you think on the future of it? Look,
I've been around crypto ever since I was buying drugs on the Silk Road. It is exactly what it is. I don't have strong opinions on it. Is it going to go up or down? I think it's the same as every other asset, right? Is real estate, everything is priced exactly where it should be, right? I don't have any magical insights into the market, right? I almost bought a house when I was 19, and my boss at Google talked me out of it. In retrospect, I should have bought that house. It was $240,000. Now it's worth $2 million. But, my boss at Google said this to me. He's like, George, you don't know anything about the real estate market. You don't know if it's going to go up or down. You don't know if it's a good buy or not. And a house is a very illiquid asset. I'm like, you know what? You're exactly right, right? And the same thing's true about crypto, right? I don't have any special insight. Is it going to go up? Is it going to go down? Is this coin good? Is this coin bad? I mean, I could probably talk about some that are bad, but if I talk about some that are obvious scams, right? You see something like Luna and Terra. Oh, and you're like, George, you're only predicting the one that went under. Look at synthetics, right? You look at something like synthetics, and it's trading these synthetic stocks backed by the Snacks token. What's the Snacks token? Well, it's a token that you can stake and it gives you 18% returns. This is a Ponzi.
Yeah.
Right? And I don't mean to call out synthetics, right? I'm not saying that's even bad. I'm not necessarily saying Ponzi's are bad. I'm just saying this is only sustainable in a bull market. Right? This fundamentally can't work. Yeah. So, you can do some economics 101 like that. Yes, a Ponzi scheme is defined as if new cash flows are paying out old money. If new money is paying out old money, right? Yeah. And it should be companies, it could be cryptos, it could be anything, but just, be aware of Ponzi's, and then you don't ask the question, right? A dumb investor says, that's a Ponzi, I'm not going to invest. The smart investor says, am I early? Right?
Right. Yeah.
So yeah, that's kind of my
apart from the investment side of it, you obviously did interesting work with that one company and helped that. Does the crypto space interest you technologically, or are you just nothing, not nearly as cool as AI and self-driving?
I mean, I'm pretty happy with what I did. You can go look at Capn. It's good open source code. I embedded a MIPS processor on chain that lets you verifiably run programs on the Ethereum chain. And you're like, oh, well, that's going to run really slowly, but not exactly, because you don't need to run the program. You don't need to run all n steps of the program, right? It's played as a multi-party game, so two people can, it's like a challenge response kind of thing. And with a challenge response, you can get this O of n down to O of log n, because there's only one step in which they disagree. Or you can treat it as this one step where they disagree, and then you only ever have to play that one step out on chain. So you can get two parties to agree verifiably on compute, full Turing complete, got a MIPS processor, and it's log n steps. Which, yeah, it's cool technology. You know what? The repo's been sitting there. They're not doing anything with it because decentralization doesn't matter. Decentralization theater matters. And this is the problem, crypto. Right? Don't actually make it decentralized. God, that's hard. Why not front about how it's decentralized and then get people to invest in your Ponzi?
Yep. Then get out while you can. Yep.
And get out. There we go. Buy your house.
All right. In terms of other current events, we have one of your competitors, I would say, in self-driving, Elon. buying Twitter and that whole thing going on. Any thoughts on? I know you're not a huge Twitter user, but like, what do you think of that?
You know what? I came back on Twitter because Elon bought it, right? Look, oh man, you know what? I will say this. I'm not even going to say, whether it's good or bad. It's entertaining.
Yep.
Elon's making Twitter fun. I'm like excited to be on Twitter. What's going to happen tomorrow? Like it's cool. And like, it's just, there's like a seriousness about these social networks I hated. Like, it wasn't like that. The internet didn't used to be like that. No one took like MySpace seriously. Then people started taking this stuff seriously. Oh, misinformation. This is news. Blah, 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 blah. Oh my God. I can't take this. And then Elon buys Twitter and he's like, YOLO, man. So I'm entertained and I support entertainment.
Yep. Any interest in some of Elon's tech side, SpaceX and Starlink, and do those technological problems solve or excite you?
I was an intern at SpaceX. I got offered a job. Again, I kind of felt like SpaceX was at a stage where, like similar kind of to where Comma is now. And this is when I was at SpaceX, maybe almost 10 years ago now, where there's a lot of smart people working on a really hard problem, and it's just a slow and steady grind, right? There's not like any like magic I can do or big architectural things I can fix. Like, and look, I mean, yeah, here we are years later, they're landing rockets. Like, that's amazing.
Yeah. Will you ever work at a big company again? SpaceX, Google, Facebook for different periods of time. Is that just not your vibe?
I think those three companies are all very different. I think, like, again, SpaceX is kind of like, the companies who I do work for are companies who are overcapitalized and will pay me way too much money to solve problems that they should have fixed internally. So yeah, like, I don't know if I could do that at SpaceX. Google, sad, man, sad. Google, sad, and Facebook, aka Meta, I listened to John Carmack's like Friedman, and he told Zuckerberg, he's like, look, make me the czar of the metaverse. I will make it good. Zuckerberg's like, well, that's not really how we do things here. And like, he laughed. How stupid. You're spending God knows what on Horizons Worlds, and like, it's terrible. Right? Carmack would have shown it. He could have made something cool. Right? So I don't like that. Again, that's kind of like you're literally, it's like one of the best guys in computer gaming history wants to come run your thing, and you're like, oh, well, that's not how we do things. We do things by committee. We got to make sure everyone's represented, right? As long as companies are still on this, like, we got to make sure everyone's represented. Come on, right? Like, I'm not trying to exclude people, but like, there's good ideas and there's bad ideas, right? I'm not trying to say anything about like who comes up with the ideas. I don't care. But until we can say that this is smart and this is dumb, it's not a place for me, right? Like, if we're going to treat every idea like it's equally good, all right, you're going to end up with committee mesh. You're going to end up with,
Yep. What about Carmack? What do you think of his thoughts on AI and agents and different things like that?
I'm excited to see what he does. I met him maybe 3 years ago at a conference thing, and yes, he's very, very, very passionate talking about stuff, and I think the ideas are like they're undeveloped. So it remains to see. For me to like say anything, like, I'd have to hear concretely what the idea is.
Yeah, would you go with it? Yeah, like, would you be interested in working on that sort of thing, or you just need to hear more on that?
I want to think if it's plausible, right? Like, I gotta hear like way more about the idea and things. Like, I think, I don't know. I don't know what if his is public. I'm not gonna say anything. But like, when he releases something, I'll evaluate it on its merits.
Yep. What motivates you in work? Is it purely like, man, what's the coolest, biggest problem I can work on? You've talked about other companies throwing money at you. Like, what do you care about?
I like the idea of like, if people want to hire me as a contractor to like solve something. I like solving problems. Mm-hmm. I like feeling like, man, I wrote like good code and this is like good. And I did this better, not just in like a structural way. In like your team wrote something 10x too complicated. I came in and just rewrote it and I'm like, do it like this. It's better.
Cool. I love it. George, this has been a fun interview. Wild. It's been fun to catch up on self-driving and AI and Tiny and all that you're working on. If people want to find you, what's the best way for them to come find what you're up to?
GitHub.com/geohot. Look at my GitHub, right? That's really what I'm doing, right? Everyone, you can front anywhere else, but look at my commits. Some of them are good, some of them are bad. You can see what I'm doing.
Yep. All right, that's cool. Yeah, I know GeoHot's blog also on GitHub pages somewhere. Your Twitch stream, all that stuff. So if people want to see you in action, they can get a little bit of that stuff. But always
got lighting
cool
now,
stuff. There you go. Yeah, you got it set up. So George, thanks for coming on Software Engineering Daily.
Cool. Thanks for having me.